Hello everyone, welcome back. In this video we're going to continue learning about machine learning, and in particular we're going to learn about feature selection. So here's the idea, is that using all of the columns isn't necessarily a good idea. Sometimes it's actually better to throw out some of the columns. Now you might ask yourself, why on earth would I ever do this? And it's because if two columns are effectively encoding the same information, then you are really, the more columns you use, you're essentially increasing the complexity of your model. And you could, if you had a complex model that's basically looking at the same columns twice, it could interpret those two columns different ways and essentially become another source of overfitting. So, like I said, we're going to show that sometimes getting rid of redundant, highly correlated columns is actually going to increase performance. But first, we're going to start with our standard imports, numpy, matplotlib, panda, read in the data using pd.readcsv. And then we're going to split up into a training and testing split. And then we're going to pre-process the data in the same way that we usually do, using our prep Titanic data df function. This is just copied and pasted from another video. All right. And so in this context, what we're going to use as our classifier is something called logistic regression. It's another type of classifier we haven't seen yet. So for this one, what we say is we say from sklearn linear model import logistic regression from sklearn model selection import cross-val score. LR is equal to logistic regression, and cross-val score is, okay, so in the cross-val score, we're just going to look at a cross-val score, sorry. X train, Y train, CV equals 5, and take the mean. All right, so far so good. We get 79.4% accuracy. This is really similar to some other stuff we've done so far. Only difference is that rather than using a decision tree, we use a logistic regression classifier. But the question is here, is this the best we can do? Is there a way we can make our logistic regression better? And something which you might know about logistic regressions is sometimes you have columns that experience what's called multicollinearity. And this is when columns are highly redundant and encode the same information. For example, passenger class and fare are basically telling us who's wealthy. They're more or less the same. They're not exactly the same, but they're maybe exactly the same. So putting both of these in the model might not actually be a good way to learn things. It might be a good way to overfit. So maybe we can get better results if we take one of them out. So that's what I've done here is I've created a list called calls that has all of the columns except for fare. And now what I'm going to do is I'm going to say print training with columns plus struct calls. LR is equal to logistic regression. And then cross-val score. LR X train calls Y train. CV equals 5 dot mean. All right, so now we're up to 80.2. So this is a little bit better. So throwing away information, getting rid of data. You wouldn't think it'd be a good thing. This is data science we're doing right here. Data is our gold, and we're throwing away our gold, but it still gets better. And this is because passenger class and fare, they're encoding the same information, and just including the same thing twice doesn't help, but it gives you more opportunities to overfit. Bad. Nope. So now what we're going to do is we're going to do this in a more systematic way. And we're going to do this using cross-validation to avoid peaking at the test set. So what I've done is I've written a number of different combinations here. And we're going to write a function which we're going to use for each of the combos. So I'm writing a function called def check column scores. And then we're basically just going to write the exact same code as up above. This needs to be inside of the function. And let's go ahead and give this thing some documentation. All right. So this is our general procedure for checking calls. And now we're going to loop over the possible combinations. So we're say for a combo in combos, X equals check column score, combo, print CV score is plus str np.round x3. All right, looks like I made a typo somewhere. Unsupported operator star for type, none type, and float. Oh, I forgot to add return to our function. Silly me. Functions need to return things. All right, there we go. All right, so training with just these three columns gets a 77.3% accuracy. These three gets a 79. And let's kind of scroll through and look where we get the best and the worst. Okay. So this bottom one here had all of the things, and we saw we got 79.4. The best was everything except for fare, which is right here. The worst was just passenger class and parents and children's aboard. So if you don't include sex, you completely lose any accuracy because sex is a very important column. And so we get some really good insights about which features are the most important. So that was our testing on our validation set. We think we know what's going to happen on the test set, but we should also check to see. So let's do test column score. It's going to be pretty similar to the last function. Test model performance on the data with selected columns. Print training with columns plus str calls. LR equals logistic regression. LR.fit X train, only look at the calls. Y train. LR fit. And we're going to return LR.score. X test, just the calls. Y test. So now we will say for combo in combos, X equals test column score calls print the test score is str and p.round x3. Fix this h. All right. And so what we can see is that we get 83. Oh, sorry, that should say combo, not calls. So what we see is we get similar stuff. The best is still this guy right here, which was all of the columns except for fair. The worst is when we didn't include sex in our analysis. And we see that we don't get the best results when we include all of the data. And in fact, this is no better than just looking at these three. All right, so that's it for this video. Feature selection is very tricky, but the main point is that you don't always want all of the data. You need to try to reason through what columns might be redundant and also test out your reasoning. So that's it. I'll see you again next time.